here are a bunch of propositions. Every integer is even, 1 plus 1 equals 2, etc. These are all propositions. They're assertions. They could be true or false. And the main thing we're concerned with in mathematics, the main point, is knowing which ones are true. So the main question that we're interested in is which propositions, of the many propositions that one can utter, which ones are true. And to address this, we need to decide what we mean by true, and we actually will give the word true a very specific meaning. So we will say that a proposition is true if it's provable. So we're just going to agree that true means provable. And now you have to ask me, what does provable mean? Well, a proposition is provable if it has a proof. So we need to say, what is a proof? If we can describe what is a proof, then we will be able to answer this question, or address this question, which propositions are true. Of course, answering the question is what all of mathematics is doing. So if we describe what is a proof, then those propositions for which there exists a proof, one can write down a proof, those are the ones we consider to be true. And the ones for which, well, let's not talk about false. Let's just say true. If you can write down a proof for a proposition, then we'll consider that proposition to be true. Okay, so what is a proof? So to say that a proposition is provable is to say that it can be deduced at the end of a proof. So there are kind of these words that I need to elaborate on. What does it mean to say I'm deducing something? What is a proof? Okay, so what is a proof? So a proof is going to be a certain kind of list of propositions. Pretend that these scribbles that I'm going to make are propositions. Let's make them blue scribbles. So here's a proposition, some assertion, another proposition, another proposition. A proof is going to be a list of propositions, kind of like that, where each proposition in the list follows from the previous ones by the rules of deduction. So this proposition that appears at the end, we say has been proven if this entire thing is a proof. And this entire thing is a proof if this one follows from the previous ones. Maybe it follows from this by the rules of deduction. And maybe this one follows from these two by the rules of deduction. And maybe this one over here follows from the one above. So that's a proof. A list of propositions where each proposition follows from the previous ones by the rules of logical deduction. Okay, there are a couple of things missing here. I haven't told you what are the rules of logical deduction. And also, if that were the end of the story, then one could never write a proof, because you would have to keep sort of backing up and justifying everything that you say by previous things, right? So this is justified by something. Let me use the pointer. This is justified by the line above it. This is justified by the two lines above it. This is justified by the line above it. But we have these sort of unjustified things. This one, and with the arrows that I drew, it looks like this one is also, or this one is also unjustified. So if you don't want to backtrack forever, then you need a better definition of proof. So here's going to be our definition. A proof is going to be a sequence of propositions, a list of propositions, like these blue scribbles, if you pretend they are propositions, where each proposition follows from the previous by rules of deduction, or it's an axiom. So this word axiom refers to those propositions refers to certain propositions that we declare to be true at the outset. So they are almost like the premises of a giant argument. They're just these propositions that we agree upon, and everything else that we say is meant to be a consequence of those propositions, is deduced from them somehow. So, as you can imagine, it's sort of not good to have too many axioms. I mean, imagine you're having a debate with someone. It's not good to have too many premises, right? The more you need to make your opponent agree with you on, the weaker your overall argument is. It's good to have fewer axioms, but you can't have no axioms, right? If you have no starting point, if you have no propositions to start with, then you can't deduce anything, right? You have to start with some proposition. So if we imagine these blue dots are propositions, now I'm making them dots rather than scribbles. You have to start with some propositions. So here's the world of propositions, all these dots. Some of them have to be, let's say, colored in red, declared to be axioms. So maybe these three are declared to be axioms. And the rules of deduction allow you to deduce one proposition from another. So the axioms are sort of true by default. They have a one-line proof, which is just to state themselves. And there are rules of deduction, which allow you to go from one proposition to another. And any proposition that you can reach by deducing your way out from the axioms is going to be said to be true. And the path of deduction that you take is going to be a proof. So if this is really confusing right now, have a look at the notes, do the reading associated with this, and I think if you come back and look at it again, you'll have some things to put in place of the scribbles that I'm putting down, and maybe it will make more sense. Okay, so let me summarize a little bit. So axioms are these propositions that are true or provable because we agree on them at the beginning. So it's not necessarily that we're threatening each other into agreeing on them, right? It's not, oh, this is true because I say so. It's that these are just sort of the rules of the game that we're playing. If you think of math like some kind of board game, the axioms are like the setup of the board game. It's the starting arrangement. You just agree on it with someone else because that's the game that you both want to play together. If someone rejects your axioms, then that's fine. That just means they're not playing the game that you're playing. So they have to find someone to play the game that they want to play. So the axioms are the rules that we agree on at the beginning. Then a proof is a chain of deductions from the axioms. So it's this like list of propositions where every proposition is either an axiom or deduced from previous propositions in the list. Or we could also allow propositions that were previously proven so that you don't have to repeat yourself if you have already proven something. And we'll use the word theorem. So a theorem is a proposition that we claim has a proof. So when someone says that something is, when someone makes a claim and says this is a theorem, what they're saying is there is a proof. So after they say it's a theorem, they had better convince you that there is a proof, that there is some chain of deductions from the axioms or from previously proven propositions. So one thing I have not been very clear on is what is this deduction thing? So it's supposed to be a way of going from one approved proposition, one proposition that we've accepted as proven, to another proposition that we accept. So deduction is kind of represented in this earlier diagram by these arrows. You know, if you know this is true, then you can deduce this one. That's deduction. But what are the rules of deduction? We have to be very clear on what are the rules of deduction to understand what proofs are accepted and which ones are not, which ones are actually not proofs. So if someone gives you a list of propositions and you want to know, is this a proof? You need to understand the rules of deduction to address that. And this really describes how the course is going to be split up. So the course, if you look at the lecture notes, there are two main big sections. Section 2, which is about, I can show you the table of contents. I don't know if it's visible on that tiny screen, but you've got, yeah, I don't think that's really visible. So you've got section 2, which is about logic and about deduction. So that's about these yellow arrows here. And you've got section 3, which is about set theory. In section 2, you don't have any axioms. And you don't have any particular propositions that you care about. So these dots, you don't really care about what they are exactly. So that's sort of the first couple of weeks of our course, is we're just going to focus on the arrows and not worry so much about the dots. We're going to focus on logic. These arrows represent logic. What are the rules that tell you what's a valid deduction from one proposition to another? Then in section 3, which is going to be the majority of the course, which we start, after a couple of weeks, then we're going to focus on what these dots are. At that time, we'll have a good deductive system in place, so we'll understand the arrows, and then we'll just start laying out axioms. We'll say which are the red dots in this diagram, and then we'll start proving things. We'll actually start doing mathematics. So actually, for the first couple of weeks, we're not really doing math. We're really just doing logic. We're just focusing on how to deduce things and what deductions are valid. So this is the focus of the first portion of the course. And later on, we'll actually give some specific axioms and start playing the game by the rules that we have laid out in the first couple of weeks.